Jai Hind, Jai Bharat. Welcome to AKP Physics. In the last lecture, we studied Coulomb's law. This time, we are going to discuss some easy numericals on Coulomb's law. So, we start with the first numerical. The first question is, what is the force between two small spheres having charges of 2 × 10⁻⁷ Coulomb and 3 × 10⁻⁷ Coulomb placed 30 cm apart in air? 30 cm apart in air. So the first charge is 2 × 10⁻⁷, Q2 is 3 × 10⁻⁷, distance is 0.3 meter. For solving in MKS system, we convert centimeter into meter. We use the formula F equal to 9 × 10⁻⁹ Q1 Q2 by R square. Put the values and solve. It will be 6 × 10⁻³ Newton. It will be repulsive because both the charges are positive. If the sign is not given, we take the charges as positive. Note it down. Now the second question is, calculate Coulombian force between a proton and an electron separated by 0.8 × 10⁻⁻15 meter. First of all, we have to note down the values. Q1 is proton. The charge of proton is 1.6 × 10⁻19 Coulomb. It is the standard value. We have to remember this value. The charge of electron is same, 1.6 × 10⁻19 Coulomb. It is negative. Distance is 0.8 × 10⁻15. Generally, we do not use the negative sign of the charge in the formula. If one charge is positive, one charge is negative, the force will be the force of attraction. Now we use the formula F equal to 9 × 10⁻9 Q1 Q2 by R square. Put the values and solve. It will be 360 Newton. Attraction because one positive and one negative charge attract each other. Now to come to question number 3, calculate electrostatic force between two alpha particles separated by 3.2 × 10⁻15 meter. Now alpha particle is helium nucleus. It has 2 protons and 2 neutrons. Electrons have been removed. So the charge on the alpha particle is double the charge of proton, that is 3.2 × 10⁻19. The second is also alpha particle, charge is 3.2 × 10⁻19 Coulomb. Distance is given in the question, 3.2 × 10⁻15 meters. Put the formula F equal to 9 × 10⁻9 Q1 Q2 by R square. Put the values and solve. It will be 90 Newton. It will be repulsive force because both the positive charges will repel each other. Now the next question is that the mutual electrostatic force of attraction between two small spheres carrying charges of plus 0.4 microcoulomb and minus 0.8 microcoulomb in air is 0.2 Newton. What is the separation between them? Answer is 12 centimeters. We do not use the negative sign in the formula. So first charge is 0.4 micro is 10⁻⁶. Second is 0.8 microcoulomb. Micro is again 10⁻⁶. F equal to 0.2 Newton. Write down the formula F equal to 9 × 10⁻9 Q1 Q2 by R square. In place of Q1, in place of force, we write 0.2 on the left hand side. On the right hand side, in the place of Q1, write 0.4 × 10⁻⁶. Minus 6 is micro. Q2 is 0.8 × 10⁻⁶. R square. R is unknown. Cross multiply R square on one side. After solving, we get it with the value of 0.0144 meter square. Take the square root. R is 0.12 meter, that is 12 centimeter, and this is the answer. The next question is, how far apart two electrons be if the force between them equals to the weight of electron? Now, both two electrons are there. First charge is 1.6 × 10⁻19 Coulomb. We are not taking the negative sign. The second is also electron. It is 1.6 × 10⁻19 Coulomb. Now, in the question, it is given that the force is equal to weight of electron. Now, weight is mg. It is 9 × 10⁻31, which is the mass of electron, into g, that is 9.8. So, in place of force, we write the value 9 × 10⁻31 into 9.8. Now we use the formula F equal to 9 × 10⁻9 Q1 Q2 by R square. Put the values on the left hand side. In place of force, write 9 × 10⁻31 into 9.8. On the right hand side, put 9 × 10⁻9, which is constant of proportionality. Then Q1 Q2 charges of both the electrons. R square is unknown. Take R square on one side, other numbers on the other side. Solve and take the square root. You get 5.1. But the question has another part which says, what in case of proton? So in case of proton, the in place of charges will be same because proton and electron have same values of charge. Force is mg. In this case, in place of m, that is mass, we take mass of proton, which is 1.7 into 10 power minus 27 kg. Our G is 9.8. So again we use the formula F equal to 9 10 power 9 in the last line, 9 10 power 9 Q1 Q2 by R square. In place of force, put mg, mass of proton, into G. On the right hand side, put the other values, cross multiply, take R square on one side, take the root, and you get the value 0.117 meters. The next question is, two positive charges distant 0.1 meter repel each other with a force of 18 Newton. If the sum of the charges is 9 microcoulomb, find their separate values. So there are two charges, but the values are not given. We assume that the first charge Q1 equal to x microcoulomb. Let it is x. Now Q2 becomes 9 minus x microcoulomb. Distance is 0.1 meter and F is 18 Newton. Use the formula F equal to 9 10 power 9 Q1 Q2 by R square. In place of force, write 18. On the other side, 9 10 power 9 Q1 is x into 10 power minus 6, because we have taken the first charge as x microcoulomb. In place of Q2, write 9 minus x into 10 power minus 6 upon distance square, that is 0.1 into 0.1, 2 times. Solve powers of 10. You get, divide both sides by 9. 2 on one side, and other side it will become x into 9 minus x upon 10. Cross multiply, it will become 9x minus x square equal to 20. We are getting a quadratic equation, x square minus 9x plus 20 equal to 0. Now factorize the equation. X square, in place of 9x we can write 5 and 4, because 5 4s are 20, and minus 5 and minus 4 becomes 9. In the first two terms, take x common, x minus 5. And the second two terms, take minus 4 common, x minus 5 equal to 0. Take x minus 5 common. On the other bracket, you get x minus 4. If x minus 5 equal to 0, then x will be 5 microcoulomb. If x minus 4 equal to 0, then x will be 4 microcoulomb. It means if the first charge is 4 microcoulomb, other is 5. If the first is 5, other is 4. So the answer is 4 microcoulomb and 5 microcoulomb. Now we come to question number 7. It says that the distance between two negatively charged dust particles is 1 millimeter. They repel each other with a force of 4 into 10 power minus 5 Newton. If the charge on one is 4 times that of the other, then calculate the number of electrons charging them separately. In this question, the charge of electron is given. Standard value is 1.6 into 10 power minus 19 coulomb. But for this question, the value is given 5 by 3 into 10 power minus 19 coulomb. So now we assume that the first charge be x, the second is 4x, because it is given that the one charge is 4 times another. If first charge is x, second is 4x. Force is 10 power minus 15 meter. Distance is 1 millimeter. We convert it into meter. It is 10 power minus 3 meter. In the third line, we use the formula F equal to 9 10 power 9 Q1 Q2 by R square. In place of force, write 4 into 10 power minus 5 equal to 9 10 power 9. Q1 is x, Q2 is 4x upon 10 power minus 6. X square on one side and others on other numbers on the other side. Cross multiply, we get 10 power minus 20 by 9. Take under root both sides, so x becomes 10 power minus 10 by 3. Calculator is not required for this question. Now the value of first charge we calculate 10 power minus 10 upon 3, and the second charge is 4x, which is 4 into 10 power minus 10 upon 3. But in the question, they are not asking about the charges, they are asking about the number of electrons. So applying quantization principle, that charge is whole number multiple of charge of electron, q equal to ne. For the first charge, 10 power minus 10 upon 3 equal to n1 into e, and the value of e is 5 by 3 in 10 power minus 19. So n1 is 10 power 9 upon 5, it becomes 2 into 10 power 8. And for the second charge, q equal to ne, again same formula. In place of q, write 4 into 10 power minus 10 upon 3. n2 is unknown, e is 5 by 3 10 power minus 19. So n2 is 4 into 10 power 9 upon 5, that becomes 8 into 10 power 8. So the answer is 2 into 10 power 8 and 8 into 10 power 8, number of electrons charging them separately. Now to come to question number 8. 2 point charges plus 2 microcoulomb and plus 6 microcoulomb repel each other with a force of 12 Newton. If each is given additional charge of minus 4 microcoulomb, what will be the new force? The answer is 4 Newton. We are applying the formula F equal to 9 10 power 9 Q1 Q2 by R square 2 times. Initially the charges are plus 2 and plus 6. In place of force write 12. 12 equal to 9 10 power 9. Q1 is 2 microcoulomb, so it is 2 into 10 power minus 6. Q2 is 6 microcoulomb, 6 into 10 power minus 6. R square. R square is unknown. This is equation 1. Now in the second case, when additional of minus 4 microcoulomb charge is given, then the first will have minus 2 microcoulomb charge, but we are not using the negative sign in the formula. We are writing in place of Q1 2 into 10 power minus 6. And the second charge 6 minus 4, it becomes plus 2, again 2 into 10 power minus 6 upon R square. Now we can calculate the value of R from equation 1 and put it in the equation 2. But there is another simple method that we divide both the equations. So on the left hand side we get 12 upon F2. On the right hand side we get 12 by 4, because all other things will be cancelled out. R square cancel, 9 10 power 9 minus 9 10 power 9 cancel, 10 power minus 6 cancel. So on cross multiplying we get F2 equal to 4 newtons. And this force will be attractive, because after giving negative 4 charge, minus 4 microcoulomb charge, the first sphere, first body will have minus 2, second will have plus 2, and we know that unlike charges attract each other. Now question number 9, it is a very easy question. Two identical metallic spheres A and B having charges of plus 40 microcoulomb and minus 10 microcoulomb. The distance between them is 2 meter. What is the magnitude and type of charge? So we just apply the formula F equal to 9 10 power 9 Q1 Q2 by R square. In place of Q1 we write 40 into 10 power minus 6. Q2 is 10 into 10 power minus 6, not using the negative sign. Distance is 2 meters, so we get 0.9 Newton attraction. The second statement says that they are touched to each other. Now after touching, the total charge will be distributed equally. Now what is the total charge? First has plus 40, second has minus 10, so the total is 40 minus 10, that is 30. 30 divided by 2 is 15. So now the first charge becomes 15 microcoulomb and second also becomes 15 microcoulomb. So when we calculate the force again, 9 and 9 Q1 Q2, distance is again 2, and it comes out to be 0.51 Newton. It is repulsive because both will have positive charge of 15. Now we come to question number 10. It says that two similarly and equally charged identical metal spheres A and B repel each other with a force of 2 into 10 power minus 5 Newton. A third identical sphere C is touched with A and placed at the midpoint between them. What is the net force on C? So now just read the first sentence. Two similarly and equally charged identical spheres A and B repel each other with a force of 2 into 10 power minus 5 Newton. This is the first diagram. There are two spheres A and B. Distance is unknown. They are repelling each other with a force of 2 into 10 power minus 5 Newton. We apply the formula. 2 into 10 power minus 5 is equal to 9 10 power 9 Q square upon R square, because both have equal charges Q. This is the first equation. In the second diagram, a third sphere C is touched with A. Now what happens when C is touched with A? The total charge will be distributed equally between A and C. C was uncharged. A is having charge Q. So now after touching, A has charge Q by 2 and C has also charge Q by 2. Charge of A is distributed between A and C. Charge of B remains same and C is placed just between them. There is a superposition principle which says that if many forces are acting on a charged particle, then the total or the net force is the vector sum of all forces. Now here we have to use vector. Now the concept of vector is very simple. We cannot add vector quantities directly. We have to make a diagram and we have to apply law of parallelogram. But there are shortcuts also. If there are two forces which are acting in same direction, then we add their values. If they are opposite to each other, we subtract the smaller from bigger. If they are perpendicular, we can apply a formula similar to Pythagoras theorem, that is under root a square plus b square. If two forces are making some angle theta with each other, we apply the formula under root a square plus b square plus 2ab cos theta. That we discussed in the previous video also. So now C is placed between A and B. Now this particle C will experience two forces. From the left hand side, A will repel it towards B, and from the right hand side, B will repel C towards A. So Fa is the force which is applied by A. A is applying force towards B and B is applying force towards this side. So Fb is the force applied by B. Now we calculate the values of both the forces. When we calculate the value of Fa, Fa is the force between these two charges, A and C. Fa, so Q1 is this, Q2 is this, and the distance is R by 2 because total distance was R. After putting the charges, the distance between A and C is R by 2. So Q1 is Q by 2, Q2 is Q by 2, distance is R by 2 whole squared, becomes R squared by 4. These two cancel, 4 cancels out, and we get 9 10 power 9 Q square by R square. And the value of this whole term is given in question number 1, which is 2 into 10 power minus 5. Equation number 1, 2 into 10 power minus 5 Newton. So force due to A becomes 2 into 10 power minus 5 Newton, and the direction is towards B. Now we calculate Fb. Fb is the force applied by B. Fb is acting between B and C because it force is applied by B on C. So Q1, Q2. Q1 is Q by 2, Q2 is Q, and the distance is R by 2. 9 10 power 9, Q1 is Q by 2, Q2 is Q, distance R square by 4, R by 2 whole square. 2 2s are 4, 2 goes up, it becomes 2 into 10 to the power 9 Q square by R square. So the total force on solving becomes 4 into 10 to the power minus 5 Newton. We put the value of 9 to the power 9 Q square by R square from equation 1. Now both the forces are opposite to each other. To find the net force, we will subtract smaller from bigger, and the direction of the net force will be the direction of bigger force. So after calculating the values, we come to know that Fb is bigger than Fa. So direction of the net force will be towards the bigger force. Bigger force is Fb, which is towards A. So the answer is 2 into 10 power minus 5 Newton. That is acting towards A. We have used law of parallelogram or addition superposition principle or the concept of vectors for solving this numerical. Now come to then the question number 11. It is similar to question number 12. The question says that two conducting spheres A and B of same size are situated some distance apart. Each has charge plus q coulomb and they repel each other with a force of 10 power minus 5 Newton. A third identical uncharged sphere is first touched with A, then with B, and then placed exactly between A and B. Find net force on C. First we read the first sentence. Two spheres repel each other with a force of 10 power minus 5 Newton. Apply the formula 10 power minus 5 equal to 9 10 power 9 Q square by R square. Now C is touched with A. Now what happens when C is touched with A? A having charge Q, C is neutral. After touching, A will acquire charge Q by 2, C acquires Q by 2. But after that, C is touched with B also. Now C and B, C has Q by 2, B has Q, and now they are touched. So what is the total charge? Well, total charge becomes Q plus Q by 2, that is 3Q by 2. Half of this will go to C and half will go to B. The charge of C will change, and now the charge of C will become 3Q by 4 and B becomes 3Q by 4. So in the second diagram, we have shown the final situation where A has Q by 2 charge, B has 3Q by 4 because when C was touched with B, the total charge got distributed between B and C, and final charge of the C is 3Q by 4. We have to find the net force on C as in the previous question. Now A is applying force towards right because A is repelling B towards right and B is repelling A is repelling C towards right. It is FA, force applied by A. B is repelling C towards left, force applied by B. We calculate the value of FA and FB. When we calculate the value of FA, FA is force between these two, A and C. So Q1, Q2. distance is r by 2. 9 10 power 9 q1 q2 upon distance square. 3 by 2 into 9 10 power 9 q square by r square. 9 10 power 9 q square by r square is from the first equation 10 power minus 5. So on solving it becomes 1.5 10 power minus 5 Newton. And the direction of FA is towards right. Now FB is the force between C and B. So this is Q1, this is Q2. Q1, Q2. 9 10 power 9 q1 q2 distance square. From the diagram the distance is half, that is r by 2 square. On solving it becomes 9 by 4 into 9 10 power 9 q square by r square. We separate this term because the value of this term is given in the equation 1, that is 10 power minus 5. So 9 by 4 is 2.25 10 power minus 5. Again we have to use the concept of vector. When the forces are opposite, to find the net force we subtract smaller from bigger. We come to know that FA is smaller after solving the values. 2.25 10 power minus 5, 1.5 10 power minus 5, it becomes 0.75 10 power minus 5 or 7.5 10 power minus 6 Newton. Direction is towards A because the direction of the bigger is FB, and the direction of FB is towards left. So the direction is towards particle A, or towards left we can also write. This is question